Welcome to the second part of the presentation on advanced surface detection and configuring model behaviors. If you haven't watched the first part, we invite you to consult it before continuing this video. In the first part, we described the new model parameters available in the Augment Manager and their usefulness. In this video, you will discover how to filter the different surfaces detected during an AR session and have the new interface elements explained to you. We will now launch the application and start an AR session. Let's suspend the session to focus on the new interface elements. When placing a model, a mark indicates the point where and when it can be inserted. The mark is surrounded by an area which projects a pattern onto the different types of surfaces. The hexagons identify the horizontal upwards surfaces, here the parquet. The bricks describe the vertical surfaces and the checkerboard pattern is used for the horizontal downwards surfaces. The mark can have 4 different forms. The white circle indicates that no usable area has been detected so far at this position. You can continue to scan the environment for them or move the device elsewhere. The green mark represents a valid position. The behavior parameters of the model make it possible to place it on this surface. You just need to tap the screen to insert the model. The orange mark is for a position where the model could be placed or moved but cannot because the surface type is currently filtered. You will see how the surface filter works later. To insert or move the model there, remember that you just need to include this type of surfaces again. Finally, the red mark prohibits the insertion or displacement of a model at the current position because the authorized surfaces parameter does not contain the type of surfaces located under the mark. Let's resume our AR session. As you can see, a green mark allows us to insert the model. We tap on the screen to do it. Then the model can be easily moved on the surface. We are now starting a new AR session. In the upper right corner of the screen you will find the new environment bar which can be used to view and filter currently detected surfaces. We will take a look. The environment bar includes 3 options to filter the surfaces considered when moving a model and 2 more to show and hide all surfaces detected so far. Each of the filter values allows 1, 2, or 3 types of surfaces to be used as a support for the different models that you will place in the scene. Enabling the correct option can help you easily identify the surface you want to target in a complex environment by eliminating other surfaces that might be interfering. By default, the filter allows all surfaces. To keep only the horizontal surfaces, upwards and downwards, click the first option. Choose the second to use only vertical surfaces. The 2 visibility buttons extend or restrict the display of detected surfaces. By default, the Hide option is active and only the closest neighbor of the placement mark is visible. To check all surfaces, click on the Visible option. This option is useful for knowing how the environment has been analyzed so far, and which region needs more attention to be correctly identified. In the AR session, we first activate the visibility of surfaces. Surfaces are displayed as the detection progresses. Some appear or expand, others disappear. Here, the surface of the table, part of the floor and an area on the wall were found. It can be seen that the placement mark indicates that the model can only be positioned on a horizontal surface. If we change the filter to allow only vertical surfaces, we see that the wall remains visible but that the model can no longer be placed. Changing the filter to allow horizontal surfaces excludes the wall and displays the table surface again. We see that the surface extends beyond the wall because we have not yet refined the scene enough. Finally, we insert the model. We quickly saw that the placement mark adapts to the available surfaces. Let's see how it combines with the surface filter. When the model allows surfaces similar to floors and walls, the model can be placed on any surface when the filter does not restrict them. If the filter excludes vertical surfaces, we see that an orange mark now appears where only a wall is available to place the model. When the model only allows horizontal surfaces, the red mark is visible on the vertical surfaces when they are not excluded because we cannot place the model here. As soon as the filter is set to horizontal, only horizontal surfaces with a green mark are displayed. Outside of detected surfaces, the white circle indicates that a deeper scan is needed or that there is no surface at all. We are going to use a model that can only be placed on a vertical surface. First, we scan the environment a bit and insert the model on the wall. When we move it, we see a red mark that appears here and there when our finger hovers over hidden horizontal surfaces and no vertical surfaces are available. Using the visibility option reveals the different surfaces. We now exclude vertical surfaces thanks to the filter. With this option active, the model can no longer be moved. An orange mark is displayed when we hover over the surface of the excluded wall and a red mark when we hover over the surface of the table. We are going to compare the transition behavior of two models that we configured in the first part of the tutorial. The decoration hat whose parameter is set to aligned and the curved screen whose parameter is set to fixed. First of all, we choose the decoration hat. We scan the environment to detect the surface of our table and the wall. Then we insert the model. If we move the hat from the table to the wall, you can see that the model rotates to fit the new surface and stays perfectly aligned. We now insert the curved screen. This time the model stays in the same orientation when we move it to the wall due to its transition behavior. The new parameters of a model influence the other models that you can choose to replace. In fact, the models must allow the same type of surface to be exchanged. When you click on the Change button to replace a model, the gallery you see is filtered to show you only models that are compatible with the current position. This way you don't risk putting a model in an incompatible location. Here we have placed a painting on the wall. The paint can only be replaced by a model compatible with vertical surfaces. By opening the gallery to choose the new models, we see that the other TV screens cannot be selected because they can only rest on horizontal surfaces. The new surfaces are compatible with places. When you capture a scene, the whole environment is recorded as in the previous versions. If you open and edit the scene, you will be able to move models and filter surfaces the same way you did in the AR session. The only difference is the green mark, which is not visible when you insert a model because the scene is not dynamic. Use the filter to view surfaces and know where to place your model. The technology used to scan the environment and detect surfaces is based on highlights and key points that can be tracked as the device moves. If you're trying to scan a smooth, even surface, it may be difficult to successfully identify it depending on the platform and device you're using. This is especially the case for walls or ceilings which generally have large, uniform areas. In this case, put stickers on the surfaces to help the system detect them quickly with good reliability. However, the environment and lighting conditions will often allow you to correctly detect such surfaces, as in the following sequence where a chandelier is positioned on a white ceiling. This concludes the presentation. Thank you for watching. Feel free to play with the new settings to assimilate the concepts discussed here and master them. In a while, it will be very natural for you to use them. See our article on new surfaces detection and other topics at help.augment.com.